In this video, we are going to use the bubble sort algorithm to sort this list of numbers 25, 12, 50, 104, and 0 in ascending order. The bubble sort algorithm works by taking the value in the first position of the list and comparing it to the value in the second position of the list. If the value in the second position of the list is less than the value in the first position of the list, the values are swapped, with the smaller value taking the lower position. Next, the value in the second position will be compared to the value in the third position, and once again, the smaller value takes the lower position. Next, the value in the third position will be compared to the value in the fourth position, swapping the values if necessary. This continues until the value stored in the last position is compared to the value stored in the second to last position of the list. Ultimately, this first pass on the list will set the largest value in the list to the highest position in the list. If the length of the list is represented by n, after n-1 passes, the list will be completely sorted. The list may be sorted before n-1 passes, but in the worst case, it will take a maximum of n-1 passes to sort a list using bubble sort. Let's look at an animation of the bubble sort algorithm being run on this list of numbers to get a better understanding of how it works. The list contains 5 values: 25, 12, 50, 104, and 0. First, the value stored in the first position of the list, 25, is compared to the value stored in the second position of the list, 12. Since 12 is less than 25, the values are swapped so that the smaller value, 12, takes the lower position. Next, the value stored in the second position, 25, is compared to the value in the third position, 50. In this case, 25 is less than 50, meaning the smaller value is already in the lower position, so we move on. Looking at the value stored in the third position, 50, and comparing it to the value in the fourth position, 104, we will advance to the next comparison, since 50 is less than 104 and already stored in the lower of the two positions being compared. The last comparison, on the first pass on this list of numbers, will be the value in the fourth position of the list, 104, and the value stored in the fifth and final position of the list, 0. Here, the smaller value 0 will need to be swapped with the larger value 104. In order to set the smaller value in the lower position. Now, after the first pass on the list, we can see that the list is still not completely sorted in ascending order. However, notice the largest value in the list has been sorted to the highest position of the list. In fact, after each pass on a list of values, the highest position of the unsorted values will be placed in its sorted position. So after the first pass on this list of values, the fifth position will contain the greatest value. After the second pass on this list, the fourth position will contain the second greatest value. After the third pass on this list, the third position will contain the third greatest value, and so on until the list is completely sorted. Notice the total values being compared is less each pass, as only the unsorted values are compared. The bubble sort algorithm has a time complexity of big O of n squared in the worst case and big O of n in the best case.